Hi, Algebra students. These are your notes for graphing quadratics in intercept form, day 2. So let's start with looking at this first problem. And these are pretty short notes today because they're really just going to expand a little bit on what we learned yesterday regarding intercept form. So if you remember, all the problems you looked at in your assignment and in your notes yesterday were already in factored form. The difference today is that you're going to have to start by factoring the function first. So that's the new piece here, which is why we started the week with doing a little review on how to factor quadratic functions. So all of this is going to access some prior knowledge from chapter 7. So I want you to think about all the things that we've talked about in terms of factoring, which I'll kind of review as we go, including all of the factoring patterns that we've learned throughout that unit. So let's take a look at this first problem. Y equals x squared plus 2x minus 8. This one's pretty simple. It does not have a leading coefficient. Remember, I always want to start by looking for a greatest common factor, which I do not have. So this one factors pretty easily into two binomials. Notice that the first term is just going to be x and x. My last term is negative, which means that my signs within the binomials are going to be 1 plus and 1 minus. I need factors of 8 that give me a difference of 2, and the larger needs to be positive. So I'm just using guess and test. You might be using some of those other methods that we talked about before, like that x, the x to organize your terms. Whatever works for you is fine with me. My leading coefficient here is positive, so I know that my graph is going to open up. And before we go any further, I want you to take a look at this problem, because if you notice, I'm going to scroll back to our notes from yesterday. What you might notice is that this is exactly the same problem that we looked at in number 1 from yesterday that was already in factored form. So x minus 2, x plus 4. So I will really quickly review that process with you just so that hopefully it will stick. So remember, the first thing we're going to do is set each of those factors equal to 0 and solve. So when x plus 4 equals 0 and x minus 2 equals 0, my two x-intercepts here, x equals negative 4. So my first x-intercept is at negative 4, 0. Here x equals positive 2. To find my axis of symmetry, remember it's the average of my x-intercepts. So remember, we call those P and Q. So it's x equals negative 4 plus 2 divided by 2. Negative 4 plus 2 is 2, and 2 divided by 2 is 1. So, and I am sorry, I've assigned, this is why I should show my work. That's negative 2 over 2, which is negative 1. So be careful with your signs, as always, and let's take a look at our vertex. So remember, our vertex is always going to have the x value from the axis of symmetry. So really we're saying when x equals 1, or again, negative 1, what is y? The only difference today is that instead of putting that in place of the factored form, you can just plug it right in to that original function. So we're going to say negative 1 squared plus 2 times negative 1 minus 8. So negative 1, and this really here is in parentheses. So negative 1 squared is 1. 2 times negative 1 is negative 2. And then we have minus 8. So 1 plus negative 2 is negative 1 minus 8 is negative 9. And remember, we're solving for y there. So that means when x is negative 1, y is negative 9. To find the y-intercept, that's always the value at which x equals 0. And again, a little bit different from yesterday. This time you can take x and place it into that original function. So y is equal to 0 squared plus 2 times 0 minus 8. So all of this gives me 0, so that means y just equals negative 8. So therefore, my y-intercept is at 0, negative 8. My next step is to take all of this information and put it on my graph. So I have one point at negative 4, 1 at positive 2 for my intercepts. My axis of symmetry is right here at negative 1. My vertex is at negative 1, negative 9. I'm going to extend that line there. My y-intercept is at 0, negative 8. And then don't forget to reflect this point across the y-axis, or sorry, across the axis of symmetry. And then we're going to draw a nice smooth curve. There we go. That's beautiful. And then let's see, our graph opens up, so it has a minimum value. Domain is always all real numbers. And my lowest point in my parabola is negative 9. So that means for my range, y is greater than or equal to negative 9. Okay, and again, if you look back at that example from yesterday, you'll notice all of that information is exactly the same. Let's take a look at problem number 2. This time, oops, let me get where I need to be here. Okay. So our problem is negative x squared plus 9. So the first thing I'm going to do, remember we're always looking for a greatest common factor. In this case, it is negative 1. So I'm going to factor out negative 1, and that gives me x squared minus 9. And again, as a review from chapter 7, this is one of our factoring patterns known as the difference of two squares. So when I factor that, it factors into my sum and difference pattern. So x plus 3, x minus 3. And then once I have that completely in factored form, I'm then going to set all of those factors equal to 0. And solve. So you'll notice for this first one, this is a false statement. Negative 1 cannot equal 0. So that first factor just kind of gets thrown out. And then here x equals negative 3, and here x equals positive 3. So those are my two intercepts, negative 3, 0, and positive 3, 0. For my axis of symmetry, remember I take the average of those, so negative 3 plus 3 divided by 2, and that gives me 0 divided by 2, which is just 0. So my axis of symmetry in this case is going to be 0. And if you remember from our previous learning, I said that any time we start with a quadratic function in the form of, ax squared plus c, where you have no middle term, the axis of symmetry is always going to be equal to 0. So let's take that and find our vertex. So when x equals 0, that's negative 0 squared plus 9. So y is equal to 9. So that means my vertex is at 0, 9. To find my y-intercept, I set x equal to 0. So y is equal to 0 squared plus 9. So my y-intercept, I don't need to really put that, is also at 0, 9. So you might remember we encountered this before, that when your equation is in the form of ax squared plus c, both the vertex and the y-intercept are exactly the same. So let's see how this looks on our graph. So when we plot these, we need to see if we have enough points to actually make our graph. So I have one intercept at negative 3, one intercept at positive 3, and my vertex is at 0, 9. And it looks like actually this time 3 points is going to be enough to actually draw my smooth curve. Just remember, if you need more points, you can always create a little table of values where you're choosing any values of x that are less than the x coordinate of the vertex, which in this case would be 0. So you would choose like negative 1, negative 2, plug that in, and you can find other points if you want. But I think actually this looks pretty good. Whoops. Okay, so let's go ahead and just finish this up. We probably should have said at the beginning that because our leading coefficient is negative, this one was going to open down, but we already proved that. That means it has a maximum value. And let's see if I can get this to where it needs to be, where our domain is all reals, and our y-intercept, sorry, not our y-intercept, our range is y is less than or equal to positive 9. Okay, so I want you to go ahead and try the practice for 8.5 day 2, and I will answer any questions that you have later on. Have a great night.